Broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe sharing of knowledge is key to enhance our skills and grow us as a professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is technical depth, how it could slow everything. And for today's session, we have Saranya Vedigiri. She is software engineer at eBay Incorporation. Saranya is a software engineer who has an extensive background in e-commerce and having more than 8 years of industry experience. She is involved in building large-scale applications which delight customers and is deeply passionate about creating high-quality software. She is also a committee member in Grace Cooper Conference for Women. So without any further delay, I introduce you all to our guest speaker. Over to you, Saranya.
Yeah, thanks for the introduction. I'm very glad to be a part of TechGeek to present about technical debt for today. Let me give a very short introduction about the place where I work. I work for eBay, which is an e-commerce company, and just to give you an overview of what's the scope of development in the e-commerce industry. Here is the growth which was predicted during 2013, that we will reach about 1.2 trillion in the sales in e-commerce market. And here we have that map predicted for the rest of the year from till 2017, and it's really estimated that we are going to reach 1.7 trillion in next year. So this is the amount of growth that we have currently in an e-commerce industry. And surprisingly, if we compare the retail to the e-commerce industry, we see like it's been double the growth for the last 5 years. Yeah. So without further delay, I would let's concentrate on today's topic of discussion, which is technical debt. So what exactly is technical debt, and what problem that it could cause for a software engineer, and as such the project that we develop. So right now, I mean, technical debt is nothing but when we take a project to be completed, we definitely have certain milestones that we think that we need to complete. If we complete those milestones, not 100%, but then we try to take some compromises so that we could meet the deadline. Then that becomes all those compromises that we take in the form of a poor software architecture or a poor software development, and with a really with a very bad design, or the code that we write, the compromises that we make when we write the code, all these contributes to a technical debt. So what happens to the to all these compromises that we made? So it in turn affects us by when we want to build something on top of it. So when we want to build on something on top of it, the amount of time and the amount of time that we spend to really understand what our current system is doing, and then to build something on top of it, it delays. And any new person who joins or who takes a look into our code, it becomes difficult for them to understand. So this is the problem which technical debt causes for engineers and the industry here. Moving on to the next one, there is a technical debt quadrant, how we could represent this technical debt as. So if we realize that there is this debt, and if we realize shortcuts for our system design, and we consciously make a decision that these are the shortcuts, and then that will not be addressed right now, and that will be addressed during the next phases. Those are the prudent debts which is there. Something which we know that we are going to take it later, and something that we understand that it is there and we take a note of it. But there are some reckless things that we do that we don't even, we don't even take a point to actually understand it, or we don't even realize that these give a problem. Those are nothing but reckless ones. So I would like to, ask everyone to take a moment and really think if we are really infected with this, technical debt. So if we think that we are, or if we think that we do not, it's always there that we are infected with technical debt. For example, the shortcut design strategy that we have taken would have helped us to yield a short-term benefit, but it doesn't. But in the long term, it is actually creating a problem. And all the production code which is live today definitely has debt in some form of the other. So now moving on to understand, when we take the code that we have currently in live, or the codes that we try to develop from the scratch. So how do we say that something is good code, or how do we say that something is a bad code? Any code, it may something which is easier for the person to understand, which has helped you to which has a very clean design, then all those comes as a good code. But anything which does not help to achieve this is all called as a bad code. Now, this is how we all start, right? As the life of a software engineer, when we have a clean state in hand, this is how we would like to build. We want to have a very great design. We want to have a very great code. But at the end, when everything is over, and when we realize it, it's all over, and it's all too much. It's too much of crap which has been involved. So I would like to give some sample, very simple sample codes which can be found in the live in the production, or which we actually write today on a day-to-day basis. For example, this here is a sample method which is a very long method, and it has a considerable amount of if loops, if followed by a for and for loops in it, and this results in an arrowhead situation where you have too many ifs, and the complexity of it also increases, because any person who looks into it has to really go through all the different parts, and then any changes or modifications that we have to do in this particular method becomes really difficult. So here is another sample where it is a very simple code where you have a variable which you really assign it as null, and then when you check for that variable, you do some action, but then in your try, right, you initialize that variable before, but then in the try you simply access some method in that class. So there is a very common exception which gets caught irrespective of the if loop getting executed or not. So this is a very poor design, and which could be found in most of our code. And there's another sample where we have actually declared a constant as a public static final, but then we still write an accessor method for accessing those variables irrespective of it being a constant. So moving on to some more examples. This is one more example which could be found in most of the places where we try to iterate the map, and then try to get the key of it and then access some of the objects. So instead, the right way will be to use the map entry and then get the value. And there's also a way where instead of returning an empty list or an empty map, we return a null for some of the cases, but it's always good good to return an empty one instead of returning a null. This is a more the more cleaner approach will be to return an empty list. So here is a nested if anti-pattern sample where we have always been learned that it's good to have one return per function, and we follow that very strictly, that we try to maintain only one return per function. But this results in a too much of arrowhead if loops, and it's really not necessary that we have to maintain one return per function. If there are too many conditional checks, it's always good to have more than one return statements. Even though it increases the complexity, it becomes a more clean code when it comes to having number of conditional checks. And here is an alternative way where we have used guarded class and returned few of it earlier, and then we have made all the bulk conditional checks later. So now let's discuss what are the tools which are available in market currently for identifying some of these or for measuring the technical debt. Here are some of the tools: the SonarQube plugin, the metrics, the Code Pro, CheckStyle, JBuzz, and FindBugs. So there are really a lot of number of tools which could be used for measuring the technical debt. And when it comes to the tools in turn use a number of parameters to check our code to compute all the complexities. For example, the one that we used predominantly in eBay is the SonarQube plugin for identifying the technical debt. Here is a sample report of from Sonar. So if you closely look at the sample report, it gives a lot of details for us. It's starting from the number of the number of lines of code that we have to the number of classes, the packages, and also over the right you will be able to see the technical depth percentage which has been computed based on some of the parameters and some of the measures. So I will be dealing with the measures in some time, but before that, these are some of the things available in the report. It also gives a quality index followed by the complexity factor. So the complexity factor it's measured in the percentage, and also it says how many man days has been expected for us to actually cover all the debt that has been present in the project. And over the left you also see the major issues. So the issues have been categorized as blockers, the critical stuff, the major, minor, and the information stuff. So when we click on the critical or the blocker stuffs, so you will be able to find out the exact last names, the methods, and the sample code piece where it can be a result of the magic numbers which is being used without properly having it as a constant. The numbers are being directly used in your code, or the visibility modifier problems that we have. All those samples and how to correct them is also available. So this is a sample report that we have in hand. And now let's actually look into the measures which can be done using this. How can we measure the technical depth that we have in the code? So all these tools use a certain amount of measuring parameters which are there. So one of the basic measuring parameter is the code complexity. So how complex is your code is one of the measure that we use. So what is code complexity? Code complexity is nothing but it's an excellent predictor of the defect. So if we say that if we identify our code is complex to some extent, then it is actually prone to have defects in it. The overall readability and cleanliness of the code is also covered here. Complex code, it actually makes it hard to understand and difficult to test as well. So in case we want to introduce anything new or any changes that needs to be done in such a complex code becomes difficult because all the use cases could not be covered, and in turn this results in a higher rate of defects. So here is a formula, you know, for identifying or computing the technical debt, which is a very straightforward one with all the cost of fixing the duplications and the violations, then the comments, uncovered complexity, and the cost to bring complexity below the threshold level. So now I will introduce you to some of the measures which are available, and we can discuss in deep about each of it. So here is a list of all complexity measures. So first one is the cyclomatic complexity, the n-path complexity, afferent-efferent coupling, instability, maintainability index, the depth of inheritance, and the lines of code. So lines of code is nothing but, you know, how much line of code that you have in your class, and how much you have in your methods. So cyclomatic complexity is nothing but it's the measure of independent paths in the method. For example, in the example that we have taken, so here is the example that we will consider. So in the example that we have taken, it's a very simple method which is actually has two if loops, and you know that two if loops they can and it checks there's an action which takes place if the condition is true. So here the cyclomatic complexity, it actually measures the number of independent paths in a method. For example, in whatever we have taken, the independent paths is nothing but the cyclomatic complexity. So that measure is nothing but the number of edges which we have. So here the number of edges that we have is 6, and then minus the number of nodes or the decision points that we have, and then you have to minus it with the number of exit statements. So exit statements are nothing but your return statements when it comes to the function. So the exit statement here is only 1 for us. So the cyclomatic complexity for such a small you know, example is actually is 3. So what is the suggested right number for the cyclomatic complexity? The matrix displays that figure. So anything less than 20 can be considered as a moderate risk, but anything that is more than 20, then it means it's a high it's of high risk, and it's definitely difficult for us to maintain such a code. So this is one of the important measure which is being used in the tool, and once we know this complexity, once this complexity is being measured in any of the methods and the classes, it would be highlighted in the tool, and we could go drill down and then make our function or the method simple by separating the methods, by separating the logic in the methods, or rewriting the code altogether. But one important thing to understand is it's not always easy to actually go back to the stuff that is already existing and then make it better. It's always good to actually have things in mind and then create a very clean code during the development itself. So this tool can be integrated in the development phase. So we are able to catch things earlier, and then we are able to have a clean code, and that's the clean code that we get it dropped to the QE. So we'll move on to the next measure, which is nothing but the n-path complexity. So the n-path complexity is nothing but the number of acyclic execution paths through that method. To make it simple, in very simple terms, if I have to explain it, it is the number of paths or the number of flows in the code that we have in hand. So let me take an example so it makes us even clear. So here is a function which is very simple, which takes input of 2 parameters, and then we have 2 conditional statements, and we print some details based on the conditions that we have in hand. So what do you think is the number of paths that we have with two conditional statements. That becomes the complexity measure here. So here is the answer for the n-path complexity. It is not the n-path complexity for this particular example is 4 because we have 4 best possible outcomes since we have two conditional statements. And the maximum threshold for the n-path complexity, which has been standardly followed, is the 200 is the threshold, and anything more than that, it means that we have to really work back on the method that we have in hand. So the next one is the afferent and the efferent coupling that we have. So what is efferent coupling? So this is nothing but the number of other packages that the class in the package depend upon. And what is afferent coupling? Afferent coupling is nothing but the number of other packages that depend on us. So here is an example that we can take to understand both of these measures. So we have a class, a very simple class called car, and in this class we have an instance of other classes like engine, wheel, and body. So if you take the class car, it has an instance of engine, wheel, and body. So the efferent coupling, so the number of packages that this class depends on becomes 3. And the afferent coupling of engine or any other engine or wheel or body becomes 1. So now there's a question of whether this kind of a measure is a good or bad measure, or which measure is actually good to be considered. So that depends on the project that we have in hand and the how do we want to get things. But it's always good that we maintain it, and that we do not have too much of coupling in our system. So we'll move on to the next measure, which is nothing but the instability. So instability is nothing but it is a ratio between whatever we discussed before, that is the efferent coupling and the total package together. So this produces actually a range by 0 to 1. So when we say that when the range actually moves towards 0, then it indicates a maximum stable package. That's what we want to maintain. And there's always this figure which is available in your tool. So most of the tools gives this measure, and we should always try to make sure the package is actually stable. On the other hand, if we have this measure moving towards 1, then this indicates that our package is totally unstable and that we have no incoming dependencies, but depends on a lot of other packages. So the next one is a maintainability index. So how much, so this explains how we the measure of maintaining something. So the maintainability index is a software metric which measures how maintainable our code is. It is calculated, there's a good formula for calculating all this stuff, and this measure is also available in the tools. So all of these measures, some of the tools predominantly use some measures in it, and some really highlight and use other measures. So let's move on. To the last measure that we have in hand, which is nothing but the depth of inheritance. So the depth of inheritance is nothing but the number of class definitions that extend to the root of the class. And the deeper the hierarchy, the more difficult it is to maintain, and it is to be understood where particular methods and fields are defined. So it's always good to have the good to have the depth of inheritance under control. And there is also a reference where it gives more details about this depth of inheritance. So what did we understand, by having these different measures in hand? So it actually clearly tells us the different ways that we could have our measure, and the SONAR report uses some of these measures or most of these measures to give you a technical depth count. So based on which we can once we have the package integrated with the SONAR, then we have a means to actually really understand how much our project is complex or not. So with this measure, we can try to reduce the complexity and clean our code so it becomes easier in the future. So here is some of the reference links and materials which are available. So technical depth, I tried to explain what exactly is technical depth and how it actually slows our process down, and then what are the different tools which are available to actually measure this, and what are the measures which are being considered in these tools. So what I would suggest is that every application that we create, we need to understand that there is this depth that we could create, and we always have to have any one of the tool integrated with our application, measure the depth, and try to write code very consciously. Yeah, so with this we come to the end of the presentation, and please let me know if we have any questions.
Thanks, Aranya, for such an insightful presentation on technical depth. Let us quickly take up questions now. I request you to please read out questions before answering them so that all our participants get the commendable insight. Please move to the question tab, Saranya. There you can find questions. Saranya, please move to the question tab there.
So here is yeah. So here is the first question, which says, what happens when we copy code from one project to another? Does it raise to technical depth? So obviously, if the project from which we copy the code has a considerable amount of if it has a depth already incurred in it, then we are prone to actually copy that depth as well with us. And here we have the next question from Swaroop, which is the best tool among the list. So the best tool among the list is the SONAR tool, because it has the example report that I showed. It shows a lot of details, and one good thing is you can even integrate with your JUnits. I mean your JUnit measure also can be integrated. So you just have one tool in hand which shows you the complexity, which also shows you how much of percentage of your code is being covered well with your JUnits. So I would recommend SONAR. So here is the next question from Asif Khan, which is, what approach then we should take while starting large scale applications. So what I would suggest is, if we are starting a large scale application, from the beginning, I mean, it's not something that we are building on top of something which is existing, but we are starting something fresh from the beginning, then I would suggest everyone to have to actually know that this to know that there is something called as a technical debt. And whenever when we talk about real-time projects, there's always a place where we try to take shortcuts. We try to compromise compromise the number of what do I say? Compromise so that we could reach the target soon. So all of these compromises that we take, at least we need to jot it down, in a common place in the form of an improvement, improvement bugs or issues, or in the form of Jira notes, or in your wiki pages. We have to note down all of these, and then and then when we have time for the revisits or the phase 2, we have to consider all of these. And one more thing that we suggest is, when we are doing the development from the scratch, it's always better to actually integrate with these tools. And when we try to deliver the code to the QE, we should make sure the complexity is also reduced. I'm not sure how much we here in eBay we follow that all our code is at least 60% JUnit covered when we actually hand it over to the QE. So when we take into consideration the JUnit coverage, it's also better to take into consideration the complexity. So we also try to make sure the complexity of the code is not higher. At least we resolve those critical and the major issues which we find in any of the tools that we have actually taken. Okay, so moving on to the next question from Rahul Anand, which says, you said instead of returning null, we should return empty list, etc. Okay, so I didn't get the question. So yes, that's what I said. But okay, so here's the continuation. But if we return empty list, it means we are allocating more memory. No, but this is your method, right? As long as you return and your return, see there are two things involved in it actually when we actually code. One thing is how good we understand, and and second point will be how efficient is the code. To coming to the point, both of these constitute to a technical depth. So one thing is how good or how clean is the code, and how is the other person able to understand the code. That will be one thing, and how efficient is the code will be the other thing. So if we return a null, and the method is actually a jar or some packages which has been available, and then somebody depends on this package, then he doesn't even know the knowledge of that he needs to take care of a null case as well. And that's the reason it has been well suggested that you have to return an empty list. So we have another question from Vishal, where he is asking, is there any standard for writing the code, and meaning number of lines per method and the number of lines per class? Yes, we do have we do have a standard which is actually told that from in your EDE, when the method can be only as long that we have to that you're able to read your method in one screen without scrolling down. That's like the simple measure that's been actually told by multiple people. If you see in the general forum or in some of the blogs, that's one thing which has been told. And but the tool actually has some measures, so they suggest that it should not be more than 40 or 50 lines, and they also take into consideration the complexity number involved in it. So with that, they identify that it's too much. For example, if you have a method where the cyclometry complexity goes more than 20, then it actually means that we have to split the method into smaller pieces, so your complexity reduces, and thereby you're reducing the number of lines per method as well. Okay, so I have another question from Aditya where he's asking if recursive functions increase technical depth. Yes, recursive functions do increase. Okay, so technical depth is a broader word of it. So we should actually be talking about the code complexity. Yes, it definitely increases the code complexity, and it also depends on how much you have inside your recursive method, right? So inside your recursive method, if you have too much of a form of a tree, your if loops are in the form of a tree, and your method asset is too heavy, and then it's complex, then it's going to increase your complexity code. So I have another question from Soumya, who's asking if the Sonar in Sonar it shows line coverage and code coverage. Could you explain branch coverage in Sonar? Okay, so actually in Sonar, if you take there is actually too many measures available, but we basically concentrate on the complexity level. But to answer this question specifically about I think, yeah, so line coverage is actually when you integrate with your JUnit plugin, right? So Sonar has a way where it can run all your JUnits. So that is also available in Sonar. So if you integrate with that, it actually runs all your JUnits for your current project, and it gives you a coverage based on the number of lines and the branch that you have. And you can also see, how much of the classes actually, the percentage of the classes which was actually a success, and then you have what are the failures, specifically the errors, how much of number of tests that was executed, and what is the number of lines which got skipped. All of these details are available. Okay, so we'll move on to the next question, where and Soumya, specifically with the branch. Okay, specifically with the branch, I'm not very sure, but I know that it is related with the JUnit coverage only. But if you are asking me specifically with the branch, I'm not pretty sure, but I can get back to you and post it in the TechGit forum of this presentation. So I have next question from Komal, who's asking, in cyclomatic complexity, you said that the acceptable complexity is defined as per the risk. Can you explain risk here? So when it came to cyclomatic complexity, what I actually mentioned is it's not about the risk, but there is actually a number where what is being suggested. For example, you have a simple, your class has multiple methods. The tool actually finds out what is the complexity in each of your methods. So what has been suggested, what has been suggested from some of these tools and the applications is that the complexity cannot, it has a threshold number, and then we say, and all these has been grouped into different, buckets. For example, they say that when it's less than 10, it's not much of a risk, meaning. So the risk is involved only when you, risk is in the form of how much time it's going to take when you're going to insert new code into it. What is the difficulty, for someone to understand the code. So these are the major problems, right? So one thing is maintainability. So maintainability is nothing but if you want to introduce something new, how good it is for you, that's maintainability. And if you want to, if somebody else is going to read that code, and how good it is for them to understand the code. So these are the major aspects which is being considered, and they are saying that if this index value, the cyclomatic complexity value ranges less than 20, then it does not pose a major risk, and you can live with that kind of a code. You don't have to go and rewrite it to bring the quantity to less than 10. It's okay. But if it is more than 50, then definitely you have to go and revisit your method and make sure that complexity number comes down. So here is the next question from Sendil, who's asking if we can integrate PHP unit with Sonar. So Senthil, I'm not sure about this one. I have integrated with only my Java code, and so I'm not sure about PHP. I think we can check that out online in the Sonar website, and I could also post the answer for this in the TechGig forum. Okay, so here is the next question from Parag, who's saying that, I'm working on a product. I am new to the product. I am finding it really hard to understand the code. So I would that there is a lot of technical depth. So what approach should be there to solve this issue? What should be the highest priorities to start with among these depths? So what I would suggest is that, so see, when you are starting something new, that you could integrate this tool and make sure that it has been clean. But for something which is already existing in production and live, it is also suggested that we integrate with this tool, which actually gives you the complexity number and the different the different classes and the methods where the problem exists. You could drill down to the problem. For example, the Sonar, if you see the report, all your issues are actually categorized as blocker, critical, major, minor, and informations. So it's always good to make sure all the production live code does not have the blocker, major, and critical issues. So what we do in eBay is we integrated all the production code with a Sonar plugin. We found out what is the complexity in terms of these buckets, and we created separate production bugs for blocker, critical, and major, and we made sure we resolved everything, and then we brought it down to 0. That's something that we did for cleaning up the code. So I would suggest we could follow such similar approach. Yeah, so here is the next question from Mohammed, who is asking if we can consider the design depth, architectural depth as a technical depth. Yes, those are also technical depth. Even if you don't have a documentation proper in your project, then that is also considered as a technical depth. So technical depth is like a broader word, which has many things inside it, including the shortcuts that we take in the architecture, the shortcuts that we take in our design. So all these come and all the bad code that we have. So all of these are covered under technical depth. Okay, so I have another question from Parag, who's actually saying, how can I take it up to the higher management, and what are the best points should I say to them so that they agree to solve this technical debt? So what we do is, so as I already indicated, so nobody actually, so everybody are interested to have to reap the short-term benefit, right? Nobody wants to actually spend a lot of time and have the best possible code in production. But as an engineer and developers, we could always work towards it. So what we do is, whenever we scope for a project, we consider we not only just scope for getting things done. We also add the JUnit part of it. We also add to make sure the complexity is there. And so when the code is delivered to QE, we make it as a process that you don't only deliver your project which works well if the P1, P2 cases are covered. Also have your units in place, and also have your code complexity level to some extent. So QE also starts seeing the report, and he makes sure it is an acceptable level. So I think it is more of a process change. And we definitely have to tell them with these pointers that it's going to be difficult in the future, and allocate some time. And one more pointer that I would like to tell is when it comes to the ones that are already existing in live, what we do is during our sprints, so we follow an agile process. So during our sprints, in every sprint, we allocate like 10% of everybody's time. Every individual's 10% of the time is being allocated to work on the existing live projects and to reduce their technical depth in them. So that's one thing. And let me move on to the next question, which is from Sindhuja. Will the Sonar tool or other tools help the developers during the development stage itself, or can be used to check only after completion of code? Oh, Sindhuja, it's going to help you during the development, and what I would suggest is to use during the development phase itself. But one thing that I would say for something which is already existing, right? So there are two things. One is not to create the mess. The other thing is to clean up the mess. So for not creating the mess, yes, you have to integrate it during the development phase. And if the mess is already created, then you have to really understand the impact of the mess. So that's where you are, if you integrate it even after it's present in the production, it will help you to, measure it. So I have another question which says, can Sonar be integrated with continuous integration tool like Jenkins from Sahid? Yes, Sahid, we can do this. Thanks for asking this question. And yes, we we have it integrated with Jenkins only. So so every time we give a build, we have the Sonar report also ready with us. Yes, you can do it. So here is the next question from Vishal, who is asking, if we need to check the 10 conditions for single result, how can we reduce the complexity? 10 conditions for single result. Okay, so if you really have too much of conditions that you have to check for a result, definitely in that particular method you can never decrease the complexity. Your complexity always remains, since you have 10 possible outcomes, you always have that number. So what we can do is you can make it simple. You can make the method simple by moving some portions of this into a different methods. So the complexity reduces per method, and also the readability is also very clear. Okay, so I have another question from Mohammed, who is asking, how can we differentiate the technical depth as a code depth, the one from the design, or it is an architectural depth? Okay, so the tool that we have in hand helps you to actually measure your code depth only, because we really can't identify, the tool will not help you to identify your design and your architectural things, but those are all shortcomings which we have taken it purposefully, right? So when we do a design, or when we come to an architectural solution, we always have more than one approaches with us, and we would have consciously taken one of the approaches because it is simpler, it is best, or it gives you the result in a short time, or in a moderate time based on whatever approach we have taken. So that's something that we have taken deliberately. But what we need to do is we need to make sure that in the long term that approach is scalable enough. So that's something that's there, and we could always have this documented so that in the future at least we know where we want to revisit. Yeah, thank you. I think we have come to the end of the session, and I think I've covered all the questions. Thanks for all the participants who have asked these questions. I hope I have answered most of them. And for some of the questions, I can I'll post them in the forum page directly.
Thanks, Aranya, for taking up so many questions and conducting this webinar. It was indeed a great session for us. I would also like to thank all our participants for their contribution and making this webinar a success. The recording of this webinar will be available on our forum, that is techgeek.com, in the coming days. Thank you all. Thank you, Saranya.
Thank you. Yeah.